Hey guys, Pankaj here. Welcome back. In today's statistics video, I'm going to talk about very famous plot that is nothing but QQ plot. So that stands for quantile plot. Now, why this is famous? Because this is very heavily used to prove any data, any random data, whether it is coming from Gaussian normal distribution family or not. Okay, so just to prove that given data set is a Gaussian normal or not a Gaussian distribution, we will use QQ plot. Okay, so I'll show and I'll explain with the help of whiteboard also complete theory, and later we'll prove it with the help of Python programming also. Okay, so let me share my screen. Okay, so let's read what is QQ plot basically. So in statistics, QQ is nothing but quantile plot play a very vital role to graphically analyze and compare two probability distribution by plotting their quantiles against each other. Okay, if the two distribution which we are comparing are exactly equal, then the points on the QQ plot will perfectly lie on the straight line. I'll show with the help of graph. Okay, and you can tell the type of distribution. So as I mentioned, right, before starting during starting the video, whenever we do the plotting of QQ plot, right, just by looking at the plot we can tell whether it is really a Gaussian distribution or not. Okay, if it is not, then it will be clearly visible in the plot. That is the beauty of this QQ plot. And you can tell the mean of the random data set plot just by looking at the plot by referring mean from quantile plot of Gaussian normal distribution. This also I'll show you how it was basically. So let's go ahead and use the whiteboard. Okay, so we know the property of Gaussian distribution, right? So any data set which is following Gaussian normal distribution, it will have mu sigma variance or maybe standard deviation, which is nothing but mu will be 0 and mu will be at 0, and your standard deviation is nothing but 1. Okay, so plot will exactly look like bell curve, right, where mu equal to this. So 50% of data will lie exactly left side of the mu, and another 50% data will exactly lie right side of the data. Okay, this 50% data and this another 50% of data exactly me, which is dividing basically symmetric data. Okay, exactly mu equal to 0. Now in QQ plot, what it is telling basically, whatever random data set you got, let's say you got some random data where mu is something, and you don't know right now what is your mu and what is your sigma square. This could be like mu might be 20 and sigma square is nothing but let's say 10. Okay, so you need to check whether it is following Gaussian or not. Gaussian or not. Okay, how to prove that? There will be a lot of statistical method. The best one and the most easiest one is nothing but QQ plot. So what is QQ basically? Quantile versus quantile plot. So you will be plotting plot one quantile versus other quantile. That's why one quantile versus other quantile. That's why it is called QQ plot. Okay, let me write quantile plot. Okay, so let's see how to plot them. So you will have one axis here, x-axis and y-axis. So your x-axis will follow exactly Gaussian normal distribution, where given sample is having mean equal to 0 and standard deviation equal to 1. So you take the quantile of Gaussian normal distribution, and against this, let's say you have some value here, right? So after plotting this, it will be exactly, since it is coming from Gaussian normal distribution, your quantile plot of Gaussian normal distribution will be nothing but a straight line, which will be exactly at 45 degree. Okay. Now what to plot in the y-axis? Now you have got another data set that is just to test whether it is coming from normal distribution or not, right? So what you do, you take x sample. Let's say x will be having so many values, right? So let's say assume that here we collected total 500 sample from Gaussian normal distribution. Okay, and from x whatever we got is nothing but x1, x2, x3, and this also we got 500 sample. Okay, so what you have to do, this is nothing but a vector of this. So you just sort all the values. So let's say you sorted x1 as x1 dash, and x2 dash, then x3 dash, and so on, x500 dash. Okay, after sorting you calculate the quantile. So there is a formula which I have already talked on the percentile and quantile, right? You can refer that video and calculate the quantile. After getting the quantile, right? So what you'll get? So let's say first quantile is nothing but your x1, then second quantile will be x2. So I'm just putting a superscript, okay? And third quantile is called as x3, and so on. And quantile will be all, or quantile will be from 1 to 100, right? I'll just give 100. Okay, so this is what this was from Gaussian distribution. Let's say first quartile, first quantile, then second quantile, then third quantile, then fourth quantile, and so on. G500 quantile, correct? You got all the values. So against each value, you are plotting quantile of those X data, whatever you got, correct? Now you just go ahead and plot them. So let's say this is your X1, this is your X2, this is your X3, and so on. You have total all X100 quantile. Okay? Here also we have all X100. This is for not 500, this is X100, G100. Quantile can be from 1 to 100. Okay, so if you just plot them, let's say you are plotting and all the values are exactly overlapping on this particular line. If it is exactly overlapping, then you can easily, by looking at the graph, you can easily say this is following the Gaussian normal distribution. Your X is also following or very equal to Gaussian normal distribution, just by looking at this particular graph. Okay, so that is what is QQ plot. Now let's say use another graph. Let's say you got one graph here, something like this. So this was your Gaussian normal distribution, where 0, 1, and this is nothing but your X at some mu and some sigma, correct? So you are getting some point like this. So let me just plot with bigger point. This, you got some point here, and after that it started deviating something, okay, like this. And here also it was deviating something like this. So if you see this kind of graph, right, then this means it is not following the Gaussian distribution. Maybe this could be due to some reason. Let's say your sample size is little less. Okay, so we have seen in the Gaussian normal distribution, right, or any other data, if you take more, as you go with more sample, your sample mean will be very much closer to the population mean, right? So if you increase the sample size, there are very high chance like your sample mean will be following the population mean. Okay, so this kind of deviation from the main line could be due to your sample size is very less, or you really have data which is not following the Gaussian distribution, or not following Gaussian normal. This could be real case also, right? Normal distribution. Okay, so we'll see by changing the with the help of Python, I will just take less sample and more sample also. Then you'll see the moment you start taking more and more sample, all will start falling the in the white line or the middle line. Okay, so this is another case. Okay, so remember, whenever you do QQ plot, get the sample first. Get sample. Let me mention. Get sample. It could be your Gaussian or random data. Then sort them or order. Calculate quantiles. Okay, so quantiles calculate from 1 to 100. So here also you will have 1 to 100 data points, and here also you will have 1 to 100 data. Okay, so for each 100 data of x-axis, you are plotting y-axis data. That will also be 100 data against this. And after plotting, you will see this kind of line. If your x random data is following the exactly overlapping the white line, means it is following the Gaussian normal distribution, or it is basically a Gaussian distribution. If we see a lot of deviation, means it is not following the Gaussian distribution. Okay, so that is the concept about QQ plot. Okay, so let's go ahead and plot using Python. Okay, so as usual, I'll be importing NumPy, Seaborn, plotting, and SciPy stats for probability plot. So this is the function which will help you to get the probability plot or quantile plot. Okay, so let's go ahead and generate the sample. Let's say I'm generating np dot. So first I'm going to get let me just say here normal dot, what was that function? Did I run or not? Equal to np dot random dot normal. Okay, so let me generate the data which is coming from Gaussian normal distribution. So you see here this normal function is nothing but having location. This is nothing but your mean value. Location stands for mean, where exactly at 0, and scale is nothing but your standard deviation, which is exactly 1. Okay, that is what is Gaussian normal distribution. Okay, so for timing I'll mention 0 just for you guys as a reference. Okay, even though by default it is 0 and 1, I'll mention 1. And size, let's collect 500 as I demonstrated in the whiteboard. Okay, so if you take a look at this, total 500 normally distributed data, correct? So using this probability plot, what I'll do, if you want to see like how exactly that KD plot will look, I can just show that KD plot for Gaussian normal distribution A. Okay, this is what we have seen, right? So this peak is nothing but exactly at 0 mean, and your standard deviation is 1. Okay, that's how Gaussian normal distribution will be distributed. Why these warnings are coming? I think it is deprecated, or let it be there. That's not a problem. The warning we can ignore for now. Okay, so when you plot a quantile plot of Gaussian normal distribution, it will exactly look as a middle line, straight line in the middle, exactly at the 45-degree. So now we are going to do that plot. So using SciPy stats, we can load this probability plot. Let's see what it takes. It takes the array of values, that is nothing but your x, and some other parameters also that we can ignore. So distribution is nothing but normal distribution. Okay, fit true, let it be there. Plot in case you would like to visualize. Okay, so if you give the array that is nothing but a, see what happens. It is going to calculate all 100 quantiles. Okay, and that quantile is nothing but going to be plotted. So how to plot them? We have already loaded this library, right? So instead of, in place of plot variable, you can just provide plt. So it will take that particular alias. Okay, so I'll just mention plt dot show. You see here, this is what I showed. So this particular x-axis shows your Gaussian normal distribution, which is nothing but theoretical quantiles. Okay, that's what theory says. Now, this is nothing but order values. Whatever value we got, right, Gaussian normal distribution, we sorted them and calculated their quantile. And this will be exactly same, 0, 1, 2, correct? Almost all the data points are overlapping. So it is coming from Gaussian normal distribution. You will see some variation. Why? Because sample size is less, 500, it may be less, correct? So I'll show with the help of little more sample just by changing the sample size. Let's add more samples here. So how to add that? What I'll do, I'll just copy paste this line. As you increase the sample, your fitting will be exactly overlapping with the line. So instead of 5,000, let's make 5,000. Instead of 500, let's make 5,000. Do the plotting. You see here, just compare this graph. Here we had 500 sample. Here we have 5,000, right? Take one more, let's say 50,000 samples. So as you take more and more and very high sample, right, you will see the complete data will be exactly overlapping. Okay, so this is what is your QQ plot, which will tell your given data sample is nothing but Gaussian normal distribution. So even though we just took Gaussian normal distribution sample, right, so it's quite obvious like it is going to overlap with the red line. Okay, and that's what you see, this particular data which is overlapping. Okay, now let's go ahead and take the other sample. So assume that I'm just taking some sample. So it doesn't really matter like you are taking exactly mu as 0 and scale 1. As long as you are taking sample from the normal distribution, no matter what mean or what standard deviation have, it is going to fall in the, or it is going to, their quantile is going to overlap in the red line. Okay, so I can prove this with changing mean. Let's change the mean and standard deviation of normal. So why I'm showing this, because you should not think, okay, this is going to be proven only when you have location or mean exactly at 0 and standard deviation exactly at 1. Okay, that is not true. You can take any mu and standard deviation as long as it is coming from normal distribution. Okay, so what I'll do now, I'll just change this value and you'll see it is exactly going to follow. Let's say my mean is at 10 and scale is at, let's say, 5. Okay, now you see. If you increase the more sample, then it is going to overlap, correct? 50,000 sample. You see? So this is what I just proved. So it doesn't matter which mean location you have, as long as you are getting sample from Gaussian normal distribution, it is going to overlap. Okay, now let's go ahead and take random data or random variable data which is not from normal distribution. Okay, so I'll take the same, and instead of normal, I'll just generate random int, which is not from normal distribution. Okay, and here I just need to give maybe low number and high number. Let's say I'm giving maybe 200, and here I'm just taking, let's say, 500 samples. Let's see what happens. See, this graph clearly tells, right, guys, by looking, as I mentioned in the beginning, right, just by looking at the graph, you can clearly tell this is not coming from Gaussian normal distribution, because you see a lot of deviation. You see here, middle data only few are overlapped, but after other data, like left side, extreme left and extreme right, all are deviating from the center line. Means it is not at all a normal distribution. Okay, so I'll make one video where we'll see like how we can make any random variable which is not following Gaussian normal distribution. We can transform them into Gaussian normal distribution. And again, I'll do QQ plot, and you'll see this graph. We can make this as we can make sure that this data is following the Gaussian normal distribution. And if it is really following, then it will start overlapping the red line. Okay, so we'll see in the next maybe couple of videos how to do that. Okay, so yeah, that's all I wanted to show. So this is the way to check any random data or any feature which we are going to see in the machine learning algorithm, right? Whenever you have a lot of features in the given data, you want to quickly check. Let's say you are assuming all are Gaussian normal distribution, but let's say you want to prove that they are coming from normal distribution. Go ahead and plot the QQ plot. Okay, and this QQ plot, this simple function, what it does basically, it is taking the normal value. Let me explain once again. So distribution is nothing but by it is taking by default as normal distribution, because x-axis is always going to be normal distribution, because that's where against normal distribution we are comparing other random variables, right? So even if you don't write, it's fine, because by default it is taking normal distribution. Okay, so maybe in this I'll just show you guys. By default we are taking norm. You can play with other value, but here our scope was to check with the Gaussian normal distribution. Okay, and against this you are going to plot the data which we got from a random variable. Okay, and PLT is nothing but just to plot the data. So x-axis will be your theoretical quantile, which is nothing but Gaussian quantile, and y-axis will be your order value, whatever you generated, which is not a Gaussian distribution. Okay, guys. Yeah, so that's all I wanted to show in this QQ plot. I hope you liked it and you understood the QQ mystery about the QQ plot. And I hope you can start using it whenever you start learning machine learning, or not only machine learning. If you are you have already done exploratory data analysis also, right? There also I did not show this graph because I did not talk about this before statistics, correct? So now it makes sense to do EDA again. Wherever you see numerical data, just go ahead and plot it and understand whether it is really real normal distribution, Gaussian normal distribution, or it's just picked up randomly. Okay. So as usual, I'll be uploading this in Jovian, GitHub, and Google Drive, and you can download and just give a try with different data sets. Okay, guys. So that's all about QQ plot. So if you haven't got any concept here, please leave out comment in the comment box. I'll definitely reply or help in the next video. Okay. And those who have not subscribed my video, please do not subscribe my channel. Please do subscribe. Okay. Thank you so much. Bye bye.